So in today's lab, for the very first time, we're going to allow wireless communication to our Arduino board. This actually involves a lot of moving parts, so you kind of have to do this in a very precise way. But once you get the connection made the first time, it's going to be very easy to make the connections for future times. So the first thing we're going to see is that we need to have an Arduino board connected to a USB cable. You're going to need to have this thing called a USB host shield, which is going to add the capability of a USB port to our Arduino. You're going to need to have a Bluetooth dongle, which is going to be plugged into the USB port. That's going to add Bluetooth connections to our Arduino board. You're going to have a PS3 controller, a PlayStation 3 controller, which uses the Bluetooth for communication. And you're going to need an extra USB cable to do the pairing between the board or between the Bluetooth dongle and the PS3 controller. So the first thing to do is to very carefully, if it hasn't already been plugged in, to very carefully plug the USB host into the Arduino board. Just be careful that all the wires line up before you gently push it in. And then once that's done, then you can gently push the Bluetooth dongle into the USB port. So now we have one compact device which can be used to perform the calculations we've been doing all semester, as well as connections through Bluetooth to the USB dongle. Now up here we're gonna open up a piece of example code. I'm gonna go down to examples and then scroll all the way to the bottom, USB host shield library 2.0. Then I'm going to scroll up to Bluetooth and then down to this example program, PS3BT. That's the PlayStation 3 controller with Bluetooth connection. So this program is provided to us by the people who created the USB host shield. We're going to go ahead and upload this program onto the board. And this program is going to do a lot of things, but one of the things it's going to do is it's going to allow us to pair the PS3 controller with the Bluetooth dongle. It turns out that this Bluetooth dongle here has a unique hardware address that is shared with no other hardware anywhere in the world, and this is going to give us the capability of being able to make a unique connection between the Bluetooth dongle and the PS3 controller, so that none of the other PS3 controllers in the room are going to be interfering with your communication. So you will be able to communicate only with your board, and it won't be interfered with by any of the other boards that the other students are using. Okay, I see that the program has uploaded. Now, one thing that happened when that program uploaded was that the Bluetooth dongle shared its unique MAC address. It's called a MAC address, the hardware address, the Media Access Control address. It shared it with the Arduino program. So that MAC address is now in the Arduino program. I'm going to now disconnect the Bluetooth dongle, but remember, it had to be connected when the program started so that we could download the MAC address into the Arduino board. So now I'm going to unplug that. I'm going to plug in this extra USB cable. And the other end of the USB cable, I'm going to plug that into the top of the PS3 controller. So now it's not wireless, it's wired, but I have connected the PS3 controller to the Arduino board. And now I'm going to press this PS button. So this little clear PS button makes the connection, and sometimes it doesn't work if it's plugged in first. So I'm going to go ahead and unplug it. I'll press the button. I got to tell you, this part of the process kind of becomes frustrating and a little bit iterative. So I'm going to wait for about 30 seconds. My hope is that the MAC address is being transmitted to the PS3 controller over this USB connection. But usually you have to kind of do it three times to get it to work. Now the good news is that once they get paired, you won't have to pair them again. They will, in fact, be permanently paired until you repair the PS3 controller with a different dongle. So I'm going to go ahead and unplug this, let it go for about 30 seconds there. I'm going to plug the Bluetooth dongle back in again. And if we get lucky, this will just stop flashing and it will light up the number 1, which it just did. Now, if that hadn't happened, what I would have done is I would have reset this board. So press the reset button and try that process again and allow it to flash. And then you can press here, let me go ahead and do this. If I press the PS button now, it'll turn off the controller. It'll break the connection. But then if I turn it back on again, now it's going to flash. But because it knows the MAC address and it'll remember it, it's programmed into this controller now, it remembers the MAC address, so it doesn't take very long to pair with the Bluetooth dongle again. So now we have a correct pairing. So I'm going to go up to the screen. I'm going to go to Tools, Serial Monitor, and it should say PS3 Bluetooth library started. But when it did that, it restarted the Arduino board, which broke the connection. Every time that you reset the Arduino, you'll have to reestablish the connection. So I'm going to reestablish the connection. Now it's reestablished, and now if I press buttons, if I press the up button, up appears on the screen. And if I press left, down, right, just to clarify, there's no wires. This is all wireless now. So I can press the cross, I can press the triangle, which is misspelled in the code, and I can't correct it because it's a built-in example. And if you can hear that, it also on triangle and circle, it rumbles the controller. So the controller right now is kind of vibrating in my hands a little bit, which you can control in your program. And here's the square. I also have the left 1 and the right 1 button. And then the left 2 is actually a continuous. It's an analog button. You can see that as I squeeze it, it's proportional. So it's going to vary between 0 and 255. Right 1 and then right 2 is also proportional, so you can see that as I squeeze it, it adjusts as well. You can press the start button, and so that'll show start. Select actually shows some information. So select, if I press the select button and it registers, it will show information about the status of the connection. So it says that the connector is unplugged, but of course wirelessly communicating. It says that the power rating of the battery is full, and then wireless status is Bluetooth, and it says rumble is off. So this is most useful to know what is the battery power that's in the controller. And in this case, you can see that it's full. I can also use these two, they're called analog hats. They're little thumb joysticks here. And as I adjust them up and down and left and right, here's the left hat, X and Y, and right hat, X and Y. You can see that I can continuously see what those are. And as I push them forward, you'll see that the Y values go to 0. And as I pull them backward, the Y values go to 255. As I press them left, the X values go to 0, and I press them right, the X values go to 255. So that means that the bottom right-hand corner of each is where each number should be, nearly 255. So sometimes it's hard to get it exactly in the spot where they're all 255, and up here in the corner where they should all be at or very close to 0 in the top left corner. So this is the way in which you can connect the PS3 controller, and you can observe that it has made the connection correctly because the results of pressing the buttons are appearing up on the serial monitor. Just one more time, the Bluetooth of the PS3 is communicating with this dongle. That dongle is communicating with the USB host. The USB host is communicating to the Arduino, and then that communicates over the USB cable to display the results up onto the serial monitor. And now we'll see how to use the PS3 controller, the USB host shield, and the motor driver shield to be able to use the PS3 wireless controller to control two DC motors. I've got two DC motors here that I've put these little patterns on the top just so that you can see them more easily over the internet. When you're doing the lab yourself, you won't have these patterns, but this way you can see it more easily. Now, I've already downloaded the program. I've already uploaded the program, but I haven't yet connected the PS3 controller. You'll see that none of the lights are lit. And this PS3 controller, though, has been paired with the USB dongle that's in here. So all I need to do is press the PS button, wait for a few seconds as those lights blink, and then this program has been written so that when it connects, there's a little rumble. So there's a sort of a tactile feedback as well as a visual feedback to indicate to you that it has made the connection. So what I want to do now is just show that the two different hats, so this little joystick hat and this little joystick hat, will control these two motors in both directions. So if I push this one forward, you can see that I'm starting to rotate the first motor, and its speed is proportional to how far I push it. If I push it all the way, it goes full speed, and if I go slower, it's going to slow down as well. And if I try to push it backward, it'll go the opposite direction. It may not be obvious. Here it's going clockwise, and then here it's going counterclockwise. So I have complete control over that motor using the wireless connection. Notice no wires, there's no connection directly to the microcontroller, but I am communicating to the Bluetooth dongle, then to the USB shield, which goes to the Arduino, which then goes to the motor driver, which then goes to the motor. And of course I also have control over the second motor as well. So I have bidirectional control of both motors, and I have bidirectional control of both motors at the same time. This may someday, next week, be very useful to you. So this is probably, of all of the programs that we've demonstrated in labs so far this semester, let me show you that they can go in both directions. This is probably the one that will be the most immediately useful to you, as this program could easily form the foundation of your final project for this class. The last thing we're going to study today is how to use the wireless communication to control two stepper motors. here I have 2 stepper motors, each of which has the ability to move in very precise steps, very precise increments. These motors are a little bit bigger than the ones that we have been using, so I'm going to use the external power supply. So I've got my 2 connections here. I've got it set to 6 volts. And I've also screwed 2 wires into the power terminal here. Now, I just really want to emphasize that this is one place where if you make a mistake, you can destroy the board. It doesn't have any sort of built-in protection at this port. So 2 things. First of all, pull off this black connection right here and carefully set it aside, because you don't want to lose that. You're going to need to reconnect it. Then notice, and I'm going to zoom in here so you can see it a little bit better, there is a side that has a plus terminal. So this is the plus terminal, and this is the minus terminal, the positive and the negative terminal. And I've used a red and a white wire here to help remind myself not to accidentally get those 2 backwards, because that would be very, very bad. So I'm going to take the positive terminal, I'm going to connect it to the positive terminal, and I'm going to take the negative terminal. I didn't have a white hookup wire, so I didn't have black, so I used white. And I've got now the power is connected. You can tell that the power is connected because the green LED next to power is going to be lit up. Now, by pulling this jumper right here, what we did was to separate the 2 power supplies. So the microcontroller is still getting its power from the Arduino, or from the USB connection, but now the stepper motors are getting their power from this connection right here. Then you'll upload the program, and what I've got here is the version that has the full functionality. I don't really know how to squeeze this all on the screen at the same time. Let me try to see if I can zoom out a little bit. And it is the left buttons that control the left stepper motor, and then you will modify it so that the right buttons control the right stepper motor. And then notice, check out that the red star there is used to indicate the straight up position, and this pushing the up button causes it to rotate 1 full revolution. It's very precise in the amount of revolutions and the amount of steps that it will go. I'll press the down button, it'll rotate 1 full revolution in the counterclockwise. And then interestingly, if I push the right button, these are known as micro steps. And so you can see that I can very finely adjust the position of the star. So for example, if I wanted to calibrate it so that the star was perfectly straight up and down, I might use that, and then I can use the up button to rotate so that the star will return back to the straight up position. And then of course the same thing can be done with the right motor once you modify the code. So forward or clockwise, backward or counterclockwise, and then we have the micro steps going clockwise or counterclockwise. Now once you're done, then what I would ask you to do, of course, is to disconnect the power, and then don't forget to plug this jumper back into those 2 wires. That jumper right there ensures that the next time that somebody starts to use this lab, that this motor driver is going to accept power from the USB board right up until the moment that they're going to use the stepper motors, and then they'll remove that jumper themselves.